All right, we want to solve the following compound inequalities. Graph the solution set on the number line and write in interval notation. So the first thing we're going to do is take each one of these that we're comparing. We have two inequalities. We want to solve each inequality. So the first thing I'm going to do for this one is get rid of the -4. I'm going to factor or cancel the -4. So divide both sides by -4. When I do that, I'll be left with just x plus 2. But I need to remember to switch the sign when I divide or multiply by a negative number. So this is going to be less than or equal to, and then I have a -3. So subtracting 2 from both sides to solve, we get x is less than or equal to -5. So the inequality on the right, just subtracting 8 from both sides, we get 3x is less than 3, and then dividing by 3 to cancel, the 3's cancel, leaving x is less than 1. So now we want to compare these two inequalities. So x is less than or equal to -5. So for this one, we want to graph a number line to compare. X is less than or equal to -5, so maybe something like this, less than or equal to -5, everything to the left. With the closed circle, we want to compare that to x is less than 1. So we'll draw another line, and x is less than 1. Maybe 1 is over here with an open circle to the left, less than. And our OR connector means that we want the union of these two sets. We want to represent both sets. So everything from 1 to the left will represent all values in both inequalities. So our answer, the graph of our answer would be everything to the left of 1, and then the interval notation would be from -infinity to 1 with a parenthesis. All right, the next inequality, again, we just want to solve. So we want to solve each inequality, so I'll subtract 5x, move my x terms on the left, everything else on the right, so we'll get x is less than -4. For the inequality on the right, we'll subtract 9, and we get x over 2 is less than or equal to -3. And then multiplying by 2 to cancel, we're going to get x is less than or equal to -6. So now we want to compare these two. So x is less than -4. So again, we'll just draw a number line, -4, maybe here, less than -4, be an open circle to the left. We graph everything to the left of -4. When we graph x less than or equal to -6, we had draw another line. Maybe -6 is here, less than or equal to -6 would look like that. And now the AND connector, we're basically looking for the intersection of these two sets, or the overlap. So the overlap is going to occur from -6 or from -infinity to -6. So with the closed circle at -6, everything to the left. And the interval notation would be -infinity to -6 with the bracket. And the last one, this is shorthand notation for between. If you think about, this is an AND connector, but it's a shorthand notation. We just solve for x in the center, so we'll add 6 to both sides. So from the middle, we'll have a 3/2 x, and then less than or equal to -9, and this is going to be less than -18. So now we'll multiply by a 2/3 to cancel, so we'll multiply the right side by 2/3 and the left side by 2/3. So just surround the -18 and multiply by a 2/3. So again, what we're trying to do is just get x in the middle. We don't have to worry about switching our signs. And then think about the canceling when we multiply the -9 times 2/3. We'll cancel the 3 with the 9, leaving a factor of 3. -3 times 2 is -6. Here again, the 3 and the 18 cancels, leaving a 6. So 2 times negative 6 is negative 12. So here's our answer. And when we graph this, it's just remembering it's everything between negative 12 and negative 6. So negative 12 is here, negative 6. Since it's less than negative 12, we want to open circle there. Less than or equal to negative 6, we'll have a closed circle. So this is going to be everything between. And then the interval notation, it starts at negative 12 with a parenthesis, and then it goes to negative 6 with a bracket.